Threat intelligence and security and project management sit at the intersection of foresight and structure. The intent behind these controls is to move organizations from reactive firefighting toward intelligence-driven defense, where decisions are informed by evidence rather than surprise. When we talk about intelligence-driven defense, we mean using information about potential threats and adversary behavior to anticipate and prevent harm before it occurs. Equally, embedding security across project lifecycles ensures that new systems, applications, or processes do not introduce vulnerabilities as they evolve. Together, these practices create a shared flow of inputs across risk, change, and incident processes, ensuring that the organization's security posture is measurable, repeatable, and directly tied to business priorities. This alignment transforms security from a compliance exercise into a strategic enabler that demonstrates how protection supports the organization's mission. The scope of threat intelligence, as outlined in A.5.7, extends far beyond reading news about breaches or subscribing to a feed of indicators. It is a structured discipline of collecting, analyzing, and disseminating information that gives context to emerging risks. This includes data about internal events, such as suspicious login patterns or anomalous traffic, combined with external sources like vulnerability disclosures or attack trend reports. The real value comes when this information is tailored to the organization's assets and business processes, rather than being generic. For instance, intelligence that highlights exploitation of a specific software version you use becomes actionable for system owners and incident responders. Effective programs ensure that each output directly supports operational or strategic decisions, closing the gap between information and action. To make intelligence usable, organizations must curate it from multiple tiers of sources, each with different credibility and depth. Open-source feeds and public advisories offer broad visibility, while commercial providers or information sharing and analysis centers, known as ISACs and ISOs, deliver more curated, sector-specific data. Law enforcement agencies and national certs often issue high-confidence alerts that require immediate attention. Yet internal telemetry from logs, endpoint data, and prior incidents may be the most relevant of all, since it reflects the organization's actual exposure. The art of intelligence work lies in blending these sources to form a picture of risk that is timely and trustworthy. Without this layering, teams risk chasing irrelevant alerts or overlooking patterns developing within their own networks. Building a functional production pipeline for threat intelligence is a bit like setting up an efficient supply chain. Each stage transforms raw material into something more valuable. Intake begins with triage, filtering what matters from the constant noise of data. Enrichment adds contextual details, such as tagging by affected assets, known vulnerabilities, or associated threat actors, so that analysts and responders know where to focus. Assessment then applies confidence scoring, helping prioritize what needs immediate action versus what can be monitored. Finally, outputs must be routed to the right control owners with deadlines and accountability, ensuring follow-through. This structured process prevents valuable intelligence from dying in inboxes or being dismissed as irrelevant, enabling a disciplined, outcome-oriented cycle. Threat intelligence becomes meaningful only when it is consumed and acted upon. Typical use cases include updating detection content for SIEMs, tuning alert thresholds to reduce noise, or feeding new indicators into intrusion prevention systems. Vulnerability management teams may use intelligence to prioritize patching of actively exploited flaws rather than patching everything equally. Fraud and abuse prevention programs often depend on early warnings from threat feeds to adjust controls before attackers pivot. At a strategic level, summarized threat reports support executive briefings and board updates, translating technical signals into risk language decision-makers understand. The measure of success is not in the number of feeds ingested, but in how effectively they improve these diverse operational and governance outcomes. Because intelligence without measurement is guesswork, organizations establish metrics to evaluate how effective their threat programs truly are. A common measure is the mean time from intelligence to action, often called MTTI, which tracks how quickly the organization moves from awareness to response. Another useful metric is the percentage of intelligence that leads to actual control changes, such as updated firewall rules or detection signatures. Reductions in attacker dwell time or incident rates provide evidence that intelligence is making a tangible impact. Conversely, a high false positive rate of intelligence-driven alerts may indicate that data sources need better validation. These metrics do more than report performance. They sustain trust in the program and justify continued investment. Governance and handling rules give structure and accountability to threat intelligence activities. Every piece of intelligence may come with classification levels and sharing constraints, especially when derived from partners or government channels. Proper handling ensures that confidentiality agreements and privacy obligations are respected. Attribution, the process of identifying who is behind an attack, should always include caveats about uncertainty, since overconfidence can harm credibility. Quality reviews are conducted periodically to assess whether data sources remain accurate, timely, and aligned with policy objectives. Retention and disposal rules prevent the accumulation of outdated or sensitive information. These governance mechanisms transform ad hoc collection into a disciplined practice consistent with the organization's information security management system. Despite their sophistication, many threat intelligence programs fail for predictable reasons. One major pitfall is prioritizing volume over value, collecting countless indicators without a framework for assessing their importance. Another is the disconnect between intelligence teams and the operational staff who could act on their findings. Feeds that are not validated or contextualized create alert fatigue, eroding trust in the entire system. Perhaps the most damaging failure is the absence of a feedback loop. When consumers of intelligence never report back on what was useful or actionable, the cycle stagnates. Successful programs close that loop, learning continuously which sources and formats truly drive security outcomes and which merely add noise. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Security in projects, as addressed in Control A.5, begins with a fundamental shift in thinking, treating security as a built-in requirement rather than a cosmetic addition at the end. Every project, whether it involves technology, facilities, or organizational change, introduces potential vulnerabilities if not guided by structured controls. By positioning security as a mandatory component of project governance, organizations ensure that every deliverable reflects resilience, compliance, and stakeholder trust. This expectation applies across all project types and sizes, embedding information security into the organization's DNA. When security considerations are woven into portfolio management and the project management office's governance, evidence of due diligence naturally emerges in project records, creating transparency for audits and confidence for executives overseeing risk. Security gating throughout the project lifecycle acts as a quality assurance mechanism for risk. The concept phase includes early screening to flag high-risk initiatives, allowing leadership to evaluate feasibility and needed mitigations before funding begins. During design, architectural reviews help teams validate that proposed patterns follow secure-by-design principles and that sensitive data paths are clearly mapped. Pre-go-live checks ensure controls are implemented, documented, and verified before approval. Post-implementation reviews close the loop, gathering lessons learned for future projects. These security gates are not bureaucratic obstacles. They serve the same function as engineering checkpoints in manufacturing, finding weaknesses before they can reach production, saving both time and credibility. Clarity and responsibilities ensures that security in projects is executed with accountability rather than assumption. The project manager carries responsibility for tracking and ensuring completion of all security-related activities within timelines and budgets. A security architect supports these efforts by advising on design decisions that align with the organization's established risk appetite and control frameworks. Control owners provide tangible acceptance criteria defining what constitutes a secure outcome and validate their implementation. Finally, the business sponsor authorizes any residual risk, ensuring risk decisions remain a matter of governance, not delegation. This structure establishes a clear chain of accountability that protects both the organization and the individuals involved from uncertainty or finger-pointing later in the process. Auditable evidence of control integration is crucial for proving that security requirements were met throughout the project's execution. Scope statements should explicitly define the security requirements alongside business objectives, confirming that protective measures are not optional enhancements. Threat models and data flow diagrams must be created and retained to show how risks were identified and mitigated. Test plans should include negative and abuse cases to verify how systems handle misuse, not just normal operations. At the final decision stage, go or no-go documentation with security sign-offs demonstrates that key stakeholders approved the release with full understanding of its risk posture. Together, these artifacts create a defensible record of compliance and diligence that can withstand internal and external scrutiny. Modern development practices demand that security keeps pace with agile and continuous delivery methods. Security must appear in user stories, backlog items, and acceptance criteria to ensure it is considered at the same level as functionality. Continuous integration and deployment pipelines should include automated checks for vulnerabilities and dependencies, accidental exposure of secrets, and compliance with configuration baselines. Static and dynamic application testing, performed automatically during builds, provides immediate feedback to developers, reducing rework later. Maintaining a software bill of materials, or SBOM, further strengthens transparency by cataloging components used in each release, making it easier to assess exposure when new vulnerabilities are disclosed. In essence, these practices align security assurance with development velocity rather than opposing it. Measuring the success of security integration in projects relies on quantifiable indicators. One common metric is the percentage of projects that successfully complete all defined security gates, an indicator of process maturity and consistency. Another is the defect escape rate, which tracks how many security issues surface after go-live, signaling gaps in earlier phases. Time to remediate pre-production findings reflects the organization's responsiveness to known risks before they become public vulnerabilities. Tracking repeat findings across releases reveals whether lessons learned are being effectively applied or ignored. These metrics help leadership see that security is not just a checkbox, but a living measure of organizational discipline and risk reduction across the project portfolio. Common pitfalls in this domain often trace back to culture and timing. Many organizations engage security too late, after major design decisions are already locked in, leaving only expensive or superficial mitigation options. Scope creep can also dilute previously agreed-upon controls, especially when delivery pressures override governance. Acceptance criteria that are vague or untestable undermine both assurance and accountability. Equally damaging is poor evidence management, when critical artifacts are stored inconsistently or outside document control systems, leaving auditors without proof of due diligence. Avoiding these pitfalls requires not only defined procedures, but also a mindset of partnership between project teams and security professionals, where early collaboration replaces late-stage confrontation. The synergy between A.5.7 and A.5.8 reveals how intelligence and structured project management reinforce one another. Threat intelligence feeds directly into project threat models, allowing designers to anticipate adversarial tactics and choose appropriate controls. Conversely, new projects produce telemetry, such as logs, vulnerabilities, and architecture patterns that enrich the organization's intelligence base. Shared metrics from both domains inform management reviews, revealing how well the organization adapts to evolving threats. Over time, this feedback loop creates a virtuous cycle of continuous improvement, where insight drives design and design strengthens insight. This integration exemplifies the ISO 2701 principle that effective security management is not static, but a dynamic system of learning and adaptation. A.5.7 and A.5.8 together set a foundation for the next layer of operational assurance. A.5.7 ensures that defense is intelligence-led, data-informed, and actionable, while A.5.8 embeds those insights into structured project delivery and governance. Measurable gates, documented evidence, and cross-domain collaboration show that the organization has matured beyond basic compliance. These controls form the bridge between strategic awareness and technical execution, ensuring that the security function is not isolated but interwoven throughout the enterprise. As we move forward to A.5.9 and A.5.10, the focus will shift from governance to tangible asset protection, showing how these strategic capabilities translate into control at the physical and digital layer of operations. As we move forward to A.5.9 and A.5.10, the focus will shift from governance to tangible asset protection, showing how these strategic capabilities translate into control at the physical and digital layer of operations.